So let's continue looking at transformations of trigonometric functions. A mass on a spring is pulled towards the floor and released, causing it to move up and down. Its height in centimeters above the floor after t seconds is given by the following function. h of t is equal to 10 sine 2 pi t minus 0.5 pi plus 15, where t is greater than or equal to 0 and less than or equal to 3. First step, let's factor out our k value. And we end up with the following equation. Remember, here's our a value, or amplitude of the function. Here's our k value, which help us find the period of the function. Remember that the period of this function is equal to 2 pi divided by the k value. So we can see that the period of this function is 1. So that means it takes 1 second to complete one cycle. Here's our phase shift, or our p value. And finally, here is our axis of the curve, or our q value. So the graph of this function, there's many ways to start. We can do a base table of sine and apply the transformations. But I'm going to try to show you a different way. What we could also do is start with our axis of the curve. And remember, that's y equals our q value, so y equals 15. Then just pick any point on the page. So let's say we're here. And we know it takes 1 second to complete a cycle. So let's just count 1, 2, 3, 4. So try to make your sine graph as big as you possibly can. So I like to count by 4 squares because then I know my max can go here and my min can go here. And let's talk about what we do next. So here's a sine graph. Next, we can draw our axes. So we know this starts at 0.25. That's our phase shift. So let's draw our y-axis, or in this case, our h-axis, h of t. Let's also include our x-axis, or in this example, t for time. So again, this value would be 0.25, and we know 1 second later, it'll repeat this sine wave. So this would be at 1.25. The halfway point, which is here, would be 0.75. The midpoint of 0.25 and 1.25. Next, we can label our y-axis. So this would be our lowest point, which is the axis of the curve minus the amplitude. So this would be 5. Here's the axis of the curve, which we know is 15. And then the peak here would be the axis of the curve plus 10, which would give us 25. And how did I figure these out? Recall that the amplitude given in our expression is the a value, which is 10. And I used the axis of the curve to figure our max and min values. So there is a sketch of this graph. Part B says to use your graph to predict when the mass will be 18 centimeters above the floor as it travels in an upward direction. So let's draw a line at 18. So if this is 15, this would be 20. So, right, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 18 is approximately here. There is h of t equals 18. And it says in an upward direction. So that would be the first point we see here. So if we want to make that prediction, we know that this is 0.25. So this could be 0.3, 3.5, 4, 4.5. So we just have to make a prediction. So we can say that's approximately at t equals 0.3 seconds. And again, it's just a prediction. So eventually we're going to be able to solve this equation. So for example, I can sub 18 into my equation, which is 10 sine 2 pi t minus 0.25 plus 15. And then we would rearrange, isolate for t, and determine the exact value. Example 2. Let's look at if we have the points, can we come up with the equation? So first let's sketch this graph. Notice all my y values are positive, so I'm going to start with my x-axis here. And notice all my x values are positive, so I'm going to start with my y-axis over here. We're only going from 3 to 7. And then we're going from 0 to 2 pi. So let's make pi over 2 every 3 marks. So pi over 2 plus pi over 2 is 2 pi over 2, which is pi. Add another pi over 2. Pi plus pi over 2 is going to be 3 pi over 2. And then 3 pi over 2 plus pi over 2 is 2 pi. Next, let's sketch this graph. So our first point is at 0 and 5. Our next point is at pi over 2 and 7. And then we have pi and 5, 3 pi over 2 and 3, and 2 pi and 5. So notice what it appears we have is a sine graph. And remember, this would continue on, so we can either express this as a sine graph or a cosine graph. And here are the steps that I would go through. First step, I would find the period for this function. And remember, that's the length of one cycle. And from the graph, I can already see that the length of one cycle is 2 pi. Which means that we can find our k value. Remember that k is equal to 2 pi divided by the period. So it gives me 2 pi divided by 2 pi, which means I have a k value equal to 1. So I have one parameter for my equation. Next is to find the axis of the curve. And that's pretty simple to see from the graph. So the axis of the curve from the graph we see is y equals 5. If we want to determine the axis of the curve without a graph, you would take the average of the max and the min value. So you would take the max plus the min and divide by 2. That would also find you the axis of the curve. Next up, find the amplitude. Again, from the graph, that's easy to see. We see we have an amplitude equal to 2. So that means our A value is equal to 2. And again, a formula to find the amplitude is that A is equal to the max minus the min divided by 2. And finally, we need to determine the phase shift. And this will depend on which sinusoidal function you're using. So if we're using sine theta, remember that sine theta starts on the axis of the curve and follows this pattern. And that looks just like this graph here. It starts at the axis of the curve, goes to a max, back down to a min, and back to the axis of the curve. So this one would have a phase shift of 0 if we use sine. If we use cosine, remember cosine starts at a max, goes to a min, and back up to a max. So if we're going to use cosine, we need to start at this point, which we see is equivalent to pi over 2. So if we use cosine, we have to use a p-value of pi over 2. So now we can determine or state both our equations. So therefore, y is equal to 2 sine of our k value, which is 1, and our phase shift, which is 0, which means we have sine of x, plus our q value, which is 5. Or we can write it as cosine, which is y equals 2 cosine x. Again, our k value is 1, so we just have to include our phase shift of pi over 2, and again, add 5. And we found the equation for the given sinusoidal function. All right, let's try one more. This time you're given the graph. Let's find the equation. So same steps as before. First, we need to find the period of this function. We can just look at the graph. So we can see there is where it starts on the axis of the curve, and there's where it repeats. So going all the way to here. So the length of one cycle for this function is 6. So the period is 6. And that means we can now find the k value. The k value is equal to 2 pi divided by 6, which means that k is equal to pi over 3. Next up is the axis of the curve. And again, the axis of the curve, we can see it from the graph. So for the axis of the curve, we can see from the graph that it's y equals 2. We could have just taken the max plus the min and divided by 2. Again, the amplitude we can see in the graph. That goes from 2 to 6, so we have an amplitude or an A value of 4. And if we wanted to find that without graphing, A value is the max minus the min, so 6 minus negative 2 divided by 2. And finally, our phase shift. So if we're focused, if we use sine theta, then we see we have a phase shift equal to 0 because we're starting on the axis of the curve. We're starting right here. If we're going to use cosine theta, then the phase shift P is equal to where the max starts, and we could have picked either max. So let's say we take the first one, and that looks like it's at 1.5. So again, we can state both equations. Y is equal to 4, our A value, sine of, next we need our K value, pi over 3, and then X, since there's no phase shift, we can just write it as pi over 3x, plus our Q value of 2. And cosine would be 4 cosine pi over 3 x minus 1.5 plus 2. So these two equations would graph the following function. Here are a few examples to try, and good luck.